We want to continue our discussion of factoring polynomials by now talking about some special factoring formulas. The first is the difference of two squares. So it goes like this. If a and b are real numbers, variables, or algebraic expressions, if you have a squared minus b squared, okay, that will immediately factor into a plus b times a minus b. Okay, so the difference of the square of two terms factor as the product of the sum and difference of those terms. Right, and if you were to FOIL this out, you'll see you get a times a gets me a squared, a times minus b gets me minus ab, b times a gets me plus ab, and b times minus b gets me minus b squared, and the middle terms are going to cancel out anyways. So what the goal is with this formula here is to recognize when you have the difference of two squares and to factor it using this formula. Okay, so let's do some examples here. Let's look at x squared minus 16. All right, do you recognize that 16 is a perfect square, so it would be x squared minus 4 squared? Well, then this x is my a and my 4 is my b. So this will literally factor then into a plus b times a minus b. Or you can write it as a minus b times a plus b. It doesn't matter what order you put that in. So you can write this as x plus 4 times x minus 4. Or, just so we're clear, you can write it as x minus 4 times x plus 4. It's totally fine. All right, let's try this one. 9x squared minus 25. All right, well, look here. Is 9 a perfect square? Yeah, so you could rewrite this as 3x squared minus, and then just to leave it in the same format with the parentheses, 5 squared. So now you have the difference of two quantities squared. So this is going to factor into, this is your a, and this is your b. So it's going to factor into 3x plus 5 times 3x minus 5. All right? And the more problems you do, let me try that. Let me show you this one. 100 times x squared minus 1. Might not look like it, but this is also the difference, excuse me, of two squares. So 100 x squared you can write as 10x squared, and 1 is the same thing as 1 squared. So this is my a, and this is my b. So this is literally going to factor as 10x plus 1 times 10x minus 1. All right, next let's talk about the sum or difference of two cubes. Okay, so when you're factoring the sum of two cubes, so notice there's no factor for the sum of two squares, okay? All right, so if you have a squared plus b squared, that doesn't factor. But if you have a cubed plus b cubed, this will factor as a plus b times, and then in parentheses, a squared minus ab plus b squared. Or if you have the factoring the difference of two cubes, so if you have a cubed minus b cubed, this will factor as a minus b times, and then in parentheses, a squared plus ab plus b squared. All right, let's do two problems so you can see here. Let's look at and let's factor. We'll look at x cubed minus 27. All right, well, this right here, look, I can rewrite this as x cubed. 27 is a perfect cube. It's 3 squared. So if you have a cubed minus b cubed, okay, so look, I have the difference of two cubes here, all right? Rewrite it here. You're just going to go back and follow the formula, all right? It's a minus b times, then in parentheses, a squared plus ab plus b squared. So look, my a is x, my b here is 3, so it's x minus 3, a squared, so that's x squared, a times b, so that's x times 3, so plus 3x, and then b squared, 3 squared, gets me 9. All right, let's do this last one here. Let's look at 8x cubed plus 125. Well, 8's a perfect cube, right? So I can write 8x cubed as 2x to the third power, and 125 is the same thing as 5 to the third power. So look, it's a plus b, so that's 2x plus 5, times, and then in parentheses, a squared. So 2x squared gets me 4x squared, plus, or excuse me, minus, sorry about that, minus a times b, so 2x times 5 gets me 10x, plus b squared. Well, b squared would be 5 squared, which would be plus 25. And we got it, okay? We got it. So these are just following the formulas. So let's end this now talking about an example of factoring fully. Okay, so what you want to do is whenever you factor something, this is going to involve multiple steps. So let's just see. Suppose you want to factor 3x cubed minus 30x squared plus 75x. The first thing I might recognize when I do this is there's actually a greatest common factor I can factor out. Okay, so if you look here, 3, 30, and 75, you can all factor a 3 out of. And x cubed, x squared, x, you can factor an x out of. So when you greatest common factor, you're left with x squared minus 10x plus 25. So you might be like, oh, okay, I factored out the greatest common factor, I'm done. But look inside here. Now, can you factor this trinomial? And it's like, yes, you can. What two numbers multiply? So we're just going to use the number game here. What two numbers multiply to positive 25 and sum to negative 10? Well, that's minus 5 and minus 5. So this will factor into x minus 5 times x minus 5, which you can then rewrite as 3x times x minus 5 squared. So whenever you get a problem that says factor fully, what you're going to want to do is, all right, can I factor out a greatest common factor? And then look at the polynomial that's left and see if you can apply any of the rules that we've learned in here to factor that. All right, class, I hope this lecture has helped our understanding of factoring polynomials across all the lectures that I've given on this. And and I've said this before, but practice makes perfect. So the more you practice these problems, the easier and easier it will get.